Today you're lucky because we're going to answer the age-old question of what is cloud computing? This is class 4 of the Cloud Computing Basics module. In What is Cloud Computing, we're going to talk a little bit about cloud computing history. We're also going to give you a specific definition of cloud computing, talk about its essential characteristics, contrast cloud computing definition to what is not cloud computing, go through cloud computing service models and deployment models, and touch on the different cloud computing domains. Cloud computing really actually has a history. In the first age of IT, the focus was on big infrastructure, mainframes, big point-to-point networks, centralized databases, and batch jobs. Towards the end of the first age, the green screen terminals evolved into personal computers. The networks went from hierarchical, where the mainframes was the center, to decentralized and distributed computing. Enterprises soon found themselves encased with a collection of servers and storage scattered around the world. You still did batch work, but many programs became very interactive. Infrastructure was typically linked to a specific application. These were application silos, and your more important applications demanded enterprise-grade or very expensive IT hardware and software. This period also saw the rise of databases, mostly relational databases, and specialized storage infrastructures. In the second age of cloud computing, you saw the rise of the internet. Companies like Sun, Cisco went to Web 1.0. eBay, Yahoo, Baby.com, and other companies created the first internet bubble. The development and introduction into the marketplace of easy-to-use, attractive devices that could be used by just about everyone drove more use across the internet. The biggest technical challenge was the network itself, and during the second age, this challenge was addressed. The single point of failure that was typical of mainframe networks went away, and in one fell swoop, this removed the biggest barrier to scaling. This introduced the third age, or the age of transformation on the internet. Early in the second age, Yahoo indexed the internet, and this was a real manual effort where people would sit on their computers and surf the internet looking for new websites. They would document the websites and then catalog them into an indexed page on Yahoo. This is okay for a while, but the size of the internet expanded exponentially, and mere humans couldn't keep up with the growth. Other companies tried to beat Yahoo at this game, including Alta Vista and Google. But it was Google that really leveraged the parallel nature of cloud computing and the fact that Moore's law finally caught up with storage. The rapid drop in the cost of storage and the parallel use of virtual servers really made Google stand out among all the other search engine providers. This introduced the new era of IT. In this era, the traditional IT markets had stagnated. people could no longer make money. But on the flip side, the marketplace was growing in what was known as BRIC countries. These were Brazil, Russia, India, and China, where the populations there were just jumping on top of the internet. This demanded new approaches to delivering information and information-based services. These were internet-driven and mobility-driven technologies that finally came of age. Traditional IT markets sort of went away, and the marketplace targeted all these growth opportunities. This brought the disruptors into the marketplace. Companies like Google, Amazon, and Salesforce.com really drove competitive markets and competitive pressures. And this was the introduction of the cloud computing era. So what exactly is cloud? Well, the National Institute of Standards and Technologies in the United States defined cloud computing as a model for enabling ubiquitous, convenient, on-demand network access to a shared pool of configurable computing resources, typically networks, servers, storage, applications, and services, and that these resources can be rapidly provisioned and released with minimal management effort or service provider interaction. Cloud computing is really an amalgamation of different technologies that have come together to revolutionize the delivery of information-based services. Other terms that are associated with cloud computing include network-centric, application service provider, co-location, and internet-based services. But this amalgamation of technology converged on a revolutionary and transformational service delivery model that we today refer to as cloud computing. So what are the essential characteristics of cloud computing? Well, first, rapid elasticity, the ability to scale resources both up and down as needed. To the consumer, the cloud appears to be infinite, and the consumer can purchase as much or as little computing power as they need. The second characteristic is measured service. Aspects of this cloud service are controlled and monitored by the cloud service provider. This is critical for billing, access control, resource optimization, and capacity planning. Essential to cloud computing is also on-demand self-service. This means that a consumer can use cloud services as needed without any human interaction. If you need a server or a virtual machine, you don't need to pick up the phone and call Joe. All you got to do is type in a URL, click in a few characteristics, and boom, you have your server. Another essential characteristic is ubiquitous network access. This means that the cloud service provider can deliver its capabilities over the network, and it can be accessed through standardized mechanisms by both thick and thin clients, even your smartphone. Resource pooling is also an essential characteristic. This is where a cloud service provider uses multiple pools of resources to serve its consumers via a multi-tenant model. In this model, physical and virtual resources are assigned and reassigned based upon consumer demand. There is location independence. The consumer has no control or knowledge over the exact location of where the resource is coming from. There are typically options to specify locations for consuming these resources, but that also comes at additional cost. So, what is not cloud computing? Well, you may have heard of autonomic computing and think that they must have autonomic computing with these cloud platforms. Well, autonomic computing are computing systems capable of self-management. These clouds don't manage themselves. You need people to manage them. Grid computing. Grid computing is an earlier form of cloud computing, but here you have super and virtual computers composed of clusters that are networked, and they act in concert to perform singular tasks, typically very large. Cloud computing also is not utility computing. This is where computing resources are packaged and delivered as a metered service, a lot like your water and your electricity. Once you decide to go to cloud, the first decision you have to make is what service model you're going to adopt. There are 3 service models typically associated with cloud computing. The first is infrastructure as a service, where the consumer uses fundamental computing resources like processing, storage, and networking to deliver IT capabilities. The consumer can control the operating system, applications, storage, and maybe even network. In platform as a service, or PaaS, the consumer uses a hosting environment for their applications. The user controls the application that runs in the environment, but they have no control over the operating system, hardware, or network infrastructure on which they are running. And the third service model is software as a service. In SaaS, the cloud service provider delivers a turnkey solution to the consumer. They use the application but have no control of how that application is delivered. In comparing and contrasting the different service models, the consumer gets to decide how much responsibility they're willing to give to the cloud service provider. On this chart, to the far left, are the services that the user must manage if they have an on-premise IT infrastructure. In this model, the complete stack is the responsibility of the enterprise or the user. In infrastructure as a service model, the cloud service provider has responsibility for the hardware, the network, and the virtualization technologies that are being used. In infrastructure as a service provider, the enterprise or the user has responsibility for all layers, including the operating system up. In PaaS, or platform as a service, more responsibility is offloaded to the cloud service provider. The infrastructure and the virtualization is paired with operating systems, the middleware, and the runtime environment for the application. The enterprise still, however, has responsibility for the data and the specific applications being used. Finally, to the far right, software as a service. Everything is handed over to the cloud service provider. And the enterprise user or the consumer only has to type in a URL to use the application of their choice. In this chart, this shows the diversity of infrastructure as a service providers in the cloud computing marketplace of August 2013. This only represents the top 13 providers. The reason for this chart is to show that Amazon Web Services is not the only infrastructure as a service provider out there. Once you select the service model you want for your enterprise, you now need to select the deployment model. Many times the reflexive selection is a private cloud because that's more akin to an enterprise building its own legacy IT platform. A private cloud can offer many of the benefits of a public cloud, such as elasticity and service-based. But in a private cloud, data processes are managed within the enterprise or organization. There is no third-party involvement in a private cloud. You also bear all of the cost of building, maintaining, and managing the cloud. So a private cloud is really an internal deployment where you use cloud computing technologies and approaches to deliver service-based capabilities. A private cloud can bring value via proven virtualization technologies. It also allows a gradual transition to more advanced service deployment models like public cloud and hybrid cloud. Public cloud is what we typically associated with cloud computing. In simple terms, they're characterized as being available to clients from a third-party service provider via the internet. Public, however, does not mean that it's free or inexpensive to use. It also doesn't mean that your data is publicly available. Public cloud vendors provide access control so that you can control and manage who has access to your data and applications. It's an elastic and very cost-effective means to deploy solutions. And the public cloud is provided by an independent external entity. Examples include Amazon for infrastructure as a service, Salesforce and Google, and many other cloud service providers. The key attributes of a public cloud include its provisioning from an independent third party, that it can be accessed via the web in a self-service model. There are readily available user guides for onboarding your application programming interfaces or APIs. There are contracts or agreements called service level agreements that manage the interaction and interface between the third party and the enterprise or users. And that multiple virtual machines are typically available in varying configurations based on specific requirements. These cloud resources can deliver many capabilities. For instance, Amazon provides storage, elastic compute, database services, content delivery, and others. A hybrid cloud model is a combination of public and private cloud. This allows an enterprise to take advantage of both of the benefits, but keep and maintain control of critical information and processing within their own private cloud or data center. In these scenarios, organizations blend its internal private clouds with capabilities provided from public cloud service providers. Even though this can provide improved economic and security capabilities, integration and interoperability is still an emerging challenge. In hybrid cloud, the enterprise can take advantage of the cost economics of external cloud service providers and simultaneously mitigate the risk by maintaining their internal private cloud. They also maintain skills and IT staff. Multiple clouds will work together in this hybrid cloud environment, and they're typically coordinated by a cloud service broker that federates the data, applications, user identity, and security across the multiple clouds. The cloud service broker function can be done by the enterprise itself or a trusted external third party. The final deployment model we're going to talk about is a community cloud. Community clouds are where semi-private clouds are formed to meet the needs of a designated set of related stakeholders. These communities of interest may be private for its stakeholders or may be a hybrid that integrates the respective private clouds of its members, yet enables them to share and collaborate across all of the clouds. A community cloud is controlled and used by a designated group of organizations that have shared interests and regulatory requirements. Typically, there are two cloud computing domains recognized. The one that most people understand or come in contact with is the enterprise domain, where static organizations leverage the internet for global connectivity with centralized governance and management. The lesser known domain is called the tactical cloud computing domain. In tactical cloud computing, virtual organizations, which are typically short-lived, leverage wireless networking technology to form private or public clouds and interoperable systems. This is typically associated with military organizations. So thank you very much for staying with us to learn more about exactly what cloud computing is. In the next class, we're going to discuss cloud computing use cases and give you specific examples of how the different service models and deployment models can be used. Thank you.